All right, welcome. Today, we're going to tackle one of the most fundamental and honestly, one of the most powerful concepts in all of SQL joins. Seriously, if you've ever had data in a couple of different spreadsheets or tables and thought, how do I get these to talk to each other? Well, you're in the right place. Okay, let's just jump right in with a super common problem. You know how it is, right? Your data is never just sitting in one perfect, neat little table. Nope, it's usually scattered all over the place. So the real question is, how do you pull all those scattered pieces together to tell one single coherent story? So, for example, let's say we have this first table here. It's a simple list of students. We've got their ID, their first name, but then look at that last column, batch ID. What's batch ID 1 or 2? On its own, that number doesn't really tell us much, does it? It's not super helpful. And that's where this second table comes in. Over here, we've got our list of batches. This is the missing piece of the puzzle. It's the decoder ring that connects that mysterious batch ID number to an actual human-readable batch name, like data science or web development. So that leads us to the big question, right? How do we mash these two tables together so we can see each student's name right next to the actual name of their batch? We want one clean, meaningful list. Well, the answer is our first and probably most important tool in the toolbox, the inner join. I'm not kidding, this is the absolute workhorse of combining data in SQL. You're going to use this all the time. The best way to think about it is like you're literally stitching two pieces of fabric together. An inner join looks at two tables, finds rows that match based on a rule you give it, and then combines them. It's that simple. And that rule I just mentioned, that's called the join condition. This is absolutely the most crucial part. It's where you tell SQL exactly how to connect the dots. You're basically saying, hey SQL, look at the students table. Now look at the batches table. Only connect a student to a batch if the batch ID is the exact same in both places. So here's what's happening under the hood step by step. First, SQL grabs a single student from the students table. Then it scans the entire batches table looking for one single row where that batch ID matches. And once it finds that match, boom, it combines them into a brand new, wider row. And it just does that over and over for every student. And voila, here's the final result. Look at that, it's beautiful. A single unified table that gives us exactly what we were looking for. We've got the student's name right there next to their batch's name. Problem solved. That's the magic of the inner join. Okay, so that's joining two different tables. But what if I told you you can join a table to itself? I know, it sounds a little weird, but this is a super powerful trick. Let's break down this self-join puzzle. So, check out this scenario. Imagine our students table has a new column called Buddy ID. Now, that Buddy ID just points to the student ID of another student in the very same table. So how in the world you get a list that shows a student's name next to their buddy's name? Here's the trick, and it's a clever one. You basically pretend that you have two copies of the same table. In your SQL query, you give the table two different nicknames or aliases, like S1 and S2. So you're telling SQL to treat the students table as two independent sources of data. And once you've done that, you can write a join condition just like before. You can tell SQL, hey, take the buddy ID from my first copy, S1, and match it up with the student ID from my second copy, S2. This is what actually connects each student's row to their buddy's row. It's a really cool technique. Okay, so we're feeling pretty good about inner joins, right? They're powerful, but there's a catch. They have one big limitation that can really trip you up if you're not aware of it. Let's talk about handling missing data. See, an inner join is great when everything matches up perfectly. But what happens when it doesn't? What about that brand new student who hasn't been assigned to a batch yet? Or what about a new batch that's been created but nobody's in it? What happens to them? And here's the crucial thing you have to remember about inner joins. If a row in one table can't find a match in the other table, it's just gone. Poof! It completely disappears from your results. And that can be a huge problem if you're trying to find, say, all students, including the ones without a batch. So to solve this whole disappearing data problem, we need to add a few more tools to our SQL toolkit. We need to go beyond the inner join and talk about something called outer joins. Okay, first up is the left join. Think of the left table as the first one you mention in your query. A left join says, listen, I want every single row from that left table no matter what. And if you find a match for it in the right table, great, bring that along. If not,
No problem, just put a null in its place. So this is perfect for seeing all our students, even the ones without a batch.
And as you've probably already guessed, a right join is the exact same idea, just flipped. It guarantees you get every single row from the second or right table. So, using our example, this would be great if we wanted to see a list of all our batches, even the ones that don't have any students in them yet. And then there's the big one, the full outer join. This is basically the give me absolutely everything option. It returns all the rows from the left table and all the rows from the right table. It'll match them up where it can, and for anything that doesn't have a match on either side, it'll just show nulls. This gives you the complete picture. Who's matched up, and just as important, who isn't.
All right, before we finish up, I want to give you a couple of pro tips. These will really help you sharpen your skills, avoid common mistakes, and make your queries run a whole lot faster.
Okay, this first one is a classic point of confusion. Join versus union. Here's the absolute simplest way to remember it. Joins stitch things together horizontally, making your table wider by adding more columns. Unions stack things vertically, making your table taller by adding more rows. Stitching versus stacking. Got it? And here is a performance tip that will make your database admin love you. When you're filtering data in a join, try to put that filter in the on clause, not the where clause. Why? Because the on clause filters the data before the join happens. The where clause joins everything first, which could be millions of rows, and then filters it. It's way, way more efficient to filter early. And there you have it. From the basic inner join to the mind-bending self-join, all the way to the inclusive outer joins. You now have the fundamental toolkit to connect pretty much any data you can find. Every dataset tells a story, but usually the pieces are scattered. Now that you know how to connect them, what hidden stories are you going to uncover?